Kubernetes and GKE Part 18. This episode has 5 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is pod affinity? Here's a strong way to approach it. Pod affinity in Kubernetes is a scheduling rule that tells the system to place a pod close to other pods that match certain labels. Core idea: pod affinity controls which pods should run together on the same node, or in the same topology, like a zone or rack. It is the opposite of spreading randomly across nodes. It helps group related workloads together. Why pod affinity is used? You use it when two services communicate frequently. Reduce latency. Microservices need to be co-located. Caching layers should stay close to application pods. You want better network performance between pods. How it works: Kubernetes scheduler checks labels on existing pods, your affinity rules, available nodes and topology constraints. Then it tries to place the new pod near matching pods. Example scenario: if you have backend pods labeled app equals backend and you want frontend pods to run close to them, pod affinity rule. Example: affinity, pod affinity. The exact commands and code are in the written question bank. Nice. Let's continue. Question 2. Explain taints and tolerations. Here's a strong way to approach it. Taints and tolerations in Kubernetes are mechanisms used to control which pods are allowed to run on which nodes. They work together to implement node-level restrictions and exceptions. Core idea: taints are applied on nodes to repel pods. Tolerations are applied on pods to allow them in. So, taint equals stay away from me. Node says this. Toleration equals I can tolerate this condition. Pod says this. 1. Taints: a taint is applied to a node to prevent unwanted pods from scheduling there. Format. Key equals value. Effects of taints: 1. No schedule pods without toleration will not be scheduled. 2. Prefer no schedule. Kubernetes tries to avoid placing pods, but not strict. 3. No execute. Existing pods are also evicted immediately. Example: taint kubectl taint nodes node 1 key equals dedicated. No schedule. This means do not schedule normal pods on this node. 2. Tolerations: a toleration is defined in a pod to allow it to be scheduled onto a tainted node. It does not force scheduling, only allows it. Example: toleration tolerations. Key dedicated operator equal value. Dev effect. No schedule meaning this pod is allowed to run on nodes tainted with dedicated equals dev. No schedule. How they work together: node, taint, pod, toleration. Result: no taint any pod allowed. Taint exists, no toleration blocked. Taint exists, matching toleration allowed. Real world use cases: 1. Dedicated nodes, GPU nodes only for ML workloads. 2. System nodes only, system pods allowed. 3. Isolation, separate dev or prod workloads. 4. Critical workloads ensure important services get reserved nodes. Example scenario: node kubectl taint nodes GPU node GPU equals true. No schedule pod. Tolerations. Key GPU operator equal value. True effect. No schedule only GPU enabled pods can run their important concept. Taints repel pods. Tolerations do not attract pods. To attract pods, you need node affinity or node selector. Taints versus node affinity feature: taints and tolerations. Node affinity purpose block unwanted pods, prefer or require nodes direction. Node pod repel, pod node select. Use case: isolation, placement, control. Simple analogy: think of a club. Taint equals VIP only entry. Toleration equals I have VIP pass. Node affinity equals I want to go to this club. Interview ready. Definition: taints and tolerations in Kubernetes are mechanisms used to control pod scheduling by allowing nodes to repel certain pods using taints, while pods can explicitly declare tolerations to override these restrictions and be scheduled onto those nodes. Great. Moving on. Question 3. What are namespaces? Here's a strong way to approach it. Namespaces in Kubernetes are a way to logically divide a cluster into isolated virtual environments. Core idea: a namespace is a virtual cluster inside a cluster used to organize and isolate resources. It helps you group and separate Kubernetes objects like pods, services, and deployments. Why namespaces are used: namespaces help you separate environments, dev, staging, prod, organize teams or projects, control access using RBAC, apply resource quotas per group, avoid name conflicts. Example: you can have dev namespace development workloads, prod namespace production workloads, monitoring namespace, observability tools. Same service name can exist in different namespaces. Nginx dev, Nginx prod. How it works: every Kubernetes resource belongs to a namespace. Unless it's cluster-wide, resources are isolated logically, not physically. You must specify namespace when querying resources. Kubectl get pods and dev default namespaces in Kubernetes 1 default where resources go if no namespace is specified. 2 Kubesystem components, DNS, scheduler, controller manager. 3 Kuba publicly readable resources. 4 Kuba node lease node heartbeat information. What is isolated in namespaces? Pod services deployments config map secrets. What is not isolated? Some resources are cluster-wide. Nodes persistent volumes cluster roles custom resource definitions. CRDs. Example namespace YAML API version. V1 kind. Namespace metadata. Name. Dev resource control with namespaces you can apply. Resource quotas. CPU or memory limits per namespace. Network policies. Traffic isolation RBAC rules. Access control per namespace. Namespace versus cluster feature. Namespace cluster scope. Logical isolation. Physical infrastructure security. Soft isolation. Hard isolation. Use case. Multi-team sharing. Separate environments. Simple analogy. Think of a Kubernetes cluster as a building. Cluster equals building. Namespaces equals different floors or departments. Pods equals rooms inside those departments. Interview ready definition. A namespace in Kubernetes is a logical partition within a cluster that allows multiple virtual environments to coexist by isolating and organizing resources such as pods, services, and deployments for better management, access control, and resource allocation. Alright, next question. Question 4. Explain config maps. Here's a strong way to approach it. A config map in Kubernetes is a resource used to store non-sensitive configuration data separately from application code and container images. Core idea: config map lets you externalize configuration so pods can be changed without rebuilding images. It is used for key value configuration data. Why config maps are used? Without config map, configuration is hard-coded in the image. Any change requires rebuilding and redeploying. With config map, configuration is external. You can update config without changing the application image. What config map stores: environment variables, configuration files, command line arguments, application settings. Example: app mode equals production log level equals info db host equals miscal service. Ways to use config map. 1. Environment variables env, name, app mode value from. The exact commands and code are in the written question bank. Let's keep going. Question 5. What are secrets? Here's a strong way to approach it. Secrets in Kubernetes are API objects used to store and manage sensitive information securely, such as passwords, tokens, and keys. Core idea: secrets are like config maps, but specifically designed for sensitive data. They help avoid hard-coding credentials inside container images or code. Why secrets are used? Without secrets, passwords or API keys get exposed in code or images. Hard to rotate credentials. Security risk in shared environments. With secrets, sensitive data is managed centrally. Access can be controlled. Easier to rotate and update credentials. What secrets store? Common examples: database passwords, API tokens, TLS certificates, SSH keys, OAuth credentials. How secrets are stored: data is stored as base64 encoded values, not encrypted by default. Encryption at rest must be enabled separately in cluster config. Example: username, YWRTA4 equals admin password, CGFZC3DVCMQ equals password. Types of secrets. 1. Opaque, most common. Generic key value secrets. 2. Docker registry credentials for pulling images from private registries. 3. TLS certificates and private keys. Ways to use secrets. 1. Environment variables env, name, db password value from. The exact commands and code are in the written question bank. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.